In the past, there's been a lot of impacts modeling where somebody takes a global climate model, or GCM, does some kind of downscaling approach, and then runs it through an impacts model. And often the choices of GCM and downscaling approach end up influencing the answers, and there's not always a lot of care given to exploring the effects of those choices, nor to quantifying uncertainty. In other words, not to really lay out what do we know and how well do we know it. So what we're trying to do here is, using the best available science, describe the future climate, hydrology, and vegetation in the Pacific Northwest. We're focused on picking some relevant variables, management relevant variables, and from the beginning of this effort, we've engaged managers in the conversation about what kinds of things they would like to know to make sure that when we come out the other side that we are providing that. We want to operate and do our research at appropriate spatial scales, appropriate meaning the answers are scientifically responsible, that we're not just making pretty maps that don't really convey what we know and how well we know it. And finally, we want to work very hard to characterize the uncertainties so that we understand why we get the answers we get, and really what are the ranges of possibilities, what are the effects of different model configurations, and so on. The climate scenarios that we're using come from the new generation of climate modeling, CMIP 5. That's the Coupled Model Intercomparison Project version 5, for those of you who don't follow this as closely as you follow box scores or whatnot. It's a set of coordinated global modeling experiments where they did simulations of the 20th century, and different modeling groups around the world participated. Some of them entered different versions of their models. At the time I put this slide together, there were 38 models. I think, David, we're up to 41 or something. And then also 21st century simulations. I wrote about 25. I think it's up above 30 now. And the greenhouse gas concentrations are specified by what are called RCPs, representative concentration pathways. The experiments in CMIP 5 used 4 RCPs. We picked the one that's second lowest. That's RCP 4.5. 4.5 stands for watts per square meter global radiative forcing in the year 2100, and 8.5 is 8.5 watts per square meter. Just for reference, we're at something like 1.7 with the greenhouse gases that we've added to the atmosphere already. So these basically derive from or are consistent with different storylines about future economic and energy growth. We want to take those models and evaluate them on the regional scale, see how well they perform for these 20th century simulations that I mentioned. We also want to see how the results have changed from the previous generation of global modeling results that were completed in about 2005, which was CMIP 3. Now you'll note, if you're awake, if you've had your coffee, that CMIP 3 to CMIP 5 is skipping a number. The IPCC, Intergovernmental Panel on Climate Change, issues assessment reports. The 5th assessment report will come out in a couple of weeks. The CMIP effort is independent of IPCC, but they decided they wanted to align the numbers. So they jumped from 3 to 5, so it would be CMIP 5 and AR5, but they are different efforts. Finally, John Abotsoglu at University of Idaho had developed a method for downscaling, which is called multivariate adaptive constructed analogs, or MACA. And so most of these future runs have been downscaled with MACA. David Roop put a lot of thought and effort into different approaches to ranking models after evaluating their performance on 20th century. And so this is the ranking from best to, well, we try not to say worst, but over at the right-hand end are models that we wouldn't recommend using. It takes a while to explain the exact approach that we used to do this evaluation, but suffice it to say that it's a pretty robust way of isolating the models on the left, which perform fairly well, from those on the right. And given the large number of models available, there probably isn't a really good reason to use large numbers of models over at the right end. And I'll come back to this concept of what you get if you focus only on the best models and what you lose if you focus only on the best models. This is a fairly busy way of summarizing the CMIP3 and CMIP5 results all in one slide. This is for changes in temperature. The next slide is changes in precipitation. For each set of 4 bars, there are 2 bars on the left representing simulations from the CMIP3 runs using scenarios SRES B1 and SRES A2, and then the RCP 4.5 and 8.5 that I mentioned. The annual means are in this left clump, and then we have the seasons. Each dot represents the change projected by one model, and then there's some shaded areas indicating the 25th and 75th percentiles, and the colored bars, the thick colored bars, are the means. So a couple things to note. Guess what? If you get more greenhouse gases, you get more warming, so the red is higher than the blue. The new generation of models for similar greenhouse gas concentrations are producing a bit more warming. There are no scenarios in which there is cooling over this time scale. This is sort of mid-21st century. So every single model warms at least half a degree in every season. Some warm more like 5 degrees Celsius. So very wide spread. The other thing to note is of all the seasons, summer warms the most. Changes in precipitation are fairly small compared with natural variability, so it's not as big a story as changes in temperature. You see in every season there are a few models that produce decreases in precipitation, but most produce increases, except in summer, where the average decrease is about sort of 5 to 10%. And there are a few scenarios, especially with RCP 8.5, where it's more like a 30% decrease. So summer's warmer and drier, being the season that sort of stands out. So in words, all scenarios show warming. There's a very wide range, more warming and drying in summer than in other seasons. And broadly, the new generation of scenarios is similar, but a little bit warmer than the last generation. So the model evaluation is complete. We have a paper that's been submitted to Journal of Geophysical Research. The MACA downscaling is well underway, and we're distributing the data. A lot of people have picked them up. David talked very briefly about some regional climate modeling that we are doing with the help of tens of thousands of volunteers. This is just the trend in April snowpack on the left over 50 years. And compared with observations on the right. Moving right along, Homero is going to talk about hydrology in the next talk. I just want to shout out the sensitivity approach that Julie Vano's done. This is a way of estimating, using the Vic hydrologic model, how flows will change, linear increases or decreases for different temp and precip changes on X and Y axes. And then the climate models are all the dots. And so if you, say, only want to run a few runs, you can pick one that's in the middle, one that's at the high end, and one that's at the low end. The numbers are ranked here by model quality from that evaluation. So you can pretty well span the range of outputs just using the best models. So in general, we feel pretty confident that people are going to be able to get what they want with impacts modeling using the best models. Vegetation, MC2, Dominique will describe in the next talk. John Kim has also been playing around with this sensitivity approach, although as his poster shows, it's a little less successful for the Northwest. So the same kind of thing, you run the model, and in this case, this is the change in annual vegetation carbon. So we've made good progress in all 3 areas. The climate part is nearly complete. We are very pleased that the climate part of it already is being taken up by other researchers, and if you're interested, by all means, talk with us. The other climate science centers around the country are also picking up this concept. They like the approach of model evaluation, and so we're talking now with the Southeast CSC about doing that. And there's some more stuff coming in the next 6 months, but we'll present this all in a workshop in the spring. So thank you.